Welcome back, students. Today we are going to continue on with our unit of solving equations, except this time we are working with multi-step equations, meaning we will need two or more inverse operations in order to solve our equations. Before we get into those steps, let's look at some translating. So here we have an English sentence, and we are going to translate it into a mathematical sentence called an equation. Remember, in order to be an equation, you have to have an equal sign. So this says the sum of 7 times a number and 2 is 8. All right, so what I'm going to do is I'm going to pick out keywords or phrases, and I'm going to translate those into the mathematical symbol that they are associated with. All right, so first I have the sum. So the sum means addition. All right, so I'm going to be adding the sum of, for example, the sum of 1 and 2 is 3. So what I do there is I take 1 plus 2, and then it is 3, so equals 3. This one's a little more complicated than that. It says the sum of 7 times a number and 2 is 8. But it's very similar in the fact that I have some quantity here and another quantity, and then it gives me the sum, the answer to the addition problem is 8. All right, so 7 times a number. Okay, 7 times a number. Let's go ahead and use n to represent our number. Okay, let's not use any symbol to represent multiplication. Instead, we're just going to put the 2 together. So 7n represents 7 times a number. So 7n is 7 times a number. And this is where your addition sign is going to go. We're taking the sum of this and this. So we're adding this and this. So we're going to have 7n plus 2 is a keyword for equals 8. All right, so putting it all together, we have 7n plus 2 equals 8. All right, now, one that is very, very similar to what we just had, but slightly different. It says 7 times the sum of a number and 2 is 8. All right, so notice this started off with the sum of 7 times a number, and this is 7 times the sum. All right, so 7 times, we're going to take 7, and we're going to be multiplying it by, but I'm not actually going to use the symbol when I write it out as an equation, but I'm taking 7 times all of this. Taking 7 times all of this is 8. So the sum of a number and 2. So once again, sum means addition and tells me where I'm going to place that addition sign. So sum of a number, let's go ahead and call it n again, and 2. So putting all of this together, we're taking 7 times, but I'm not going to put the multiplication symbol. Instead, I'm just going to put them right together, and that means implied multiplication. And then I'm taking 7 times all of this. So I need to group all of this together, which means I need my parentheses. The sum of a number, so I'm taking n, and then the sum of it with 2. So the sum of n and 2 is 8. All right, so very similar equations, just the order was slightly different, which means the order of operations that we have for our two equations are slightly different. Now let's move on to our steps for how we would actually solve those equations. So how do we get n by itself? Because we can't really just think through it. We can't figure out this number times 7 and 2 more than that gives us 8. All right, that's going to be hard for us to just do in our heads. So we need a step-by-step procedure, and that's what this is. So first, I would suggest that you draw the line down the equal sign to separate the left-hand side from the right-hand side. And then simplify your two sides as much as you can. So if you need to distribute or combine like terms, do so. You need to have both sides as simplified as much as possible. Then you're going to identify which side the variable is on. Okay? And then you're going to ask yourself, what am I doing to that variable? And then you're going to undo those operations. The way that you're going to undo those operations is by using the inverse operations. So for example, addition and subtraction, they undo each other. Multiplication, division, they undo each other. Remember that as we are working, we're trying to undo, okay, which means we're going backwards as we are using our order of operations. So our order of operations, our PEMDAs, okay, our parentheses, our exponents, our multiplication, addition, or our multiplication and division, and then our addition and subtraction, okay, we're going to be working backwards. All right, so we have 2w minus 11 equals 3. So I went ahead and drew the dividing, or I drew the line that splits the left-hand side from the right-hand side. I look to see on the left-hand side, is there anything I need to simplify? 2w minus 11, those are unlike terms. I cannot combine them. 3, obviously, I can't do anything with it because it's just a number by itself. Then I identify where the variable is. So here's my variable. It's w. I'm multiplying it by 2, so I have multiplication, and I am subtracting 11. All right, so as I'm trying to undo this to work backwards to figure out what that unknown value is, I need to do my order of operations backwards, which means I need to work on getting rid of the subtraction and then getting rid of the multiplication. So to undo a minus 11, I will add 11 to both sides. And the minus 11 plus 11 cancels out, and that's going to leave me with just 2w equals, and then on the right-hand side, 3 plus 11 will give me the 14. So I got rid of my subtraction, and now I get rid of the multiplication. So 2 times w, the opposite of times is divide, so I'm going to divide by 2. So I'm going to divide both sides by 2, and that will give me, the 2 divided by 2 cancels out. That will leave me with w equals 14 divided by 2 is 7. All right, so we can double check our work. If I take 2 times 7, that's going to give me 14. 14 minus 11 is 3, so that is correct. On this next one, when I split the left-hand side from the right-hand side, I notice my left-hand side has quite a bit going on. So I'm going to try to simplify it as much as possible. I get rid of the parentheses by using the distributive property with that 4. So I'm going to take everything inside the parentheses times 4. So 4 times 2x will give me 8x. And then I'll take 4 times negative 7, which will give me negative 28. Now, I do not multiply 4 times this 4x because the 4x was not inside the parentheses. However, I do need to go ahead and bring it down to my next line because it's still a part of my equation. All right, so one more thing I need to do in order to simplify the left-hand side is combine like terms. So like terms means the same variable, same exponent. So 8x and 4x, those are like terms because they both have x to the first power, x to the first power. So I'm going to keep x to the first power, and I'm going to combine the numbers in front. So 8 and a positive 4, 8 plus 4 would make 12. All right, so 8x plus 4x is 12x. We combined those. They were on the same side, so we combined. We did not do any inverse operations. Inverse operations are when you try to move to the other side. Here, we just combined because they were on the same side. And then we still have a minus 28 equals 20. Now we identify is the variable on the left-hand side or the right-hand side. And here it is on the left-hand side. What are we doing to the variable? Well, we are multiplying it by 12 and we are subtracting 28. So once again, we have multiplication and we have subtraction. As we work to solve this, as we work to undo, we have to work backwards. So we have to get rid of the subtraction before we can get rid of the multiplication. So the way that we get rid of subtraction is by addition. So if we were subtracting 28, we are now going to add 28 to both sides. Negative 28 plus 28, those zero out, those cancel out. That's going to leave us with just 12x on the left-hand side equals, and then on the right-hand side, we have 20 plus 28, which gives us 48. Now, we got rid of the subtraction. Now we get rid of multiplication by division. We are multiplying x by 12, so we're going to do the opposite, and we are going to divide both sides by 12. And that's going to give us 12 divided by 12 cancels. That will just leave us with x equals, and then 48 divided by 12 is 4. Final answer. And you can double check by plugging it in, or here's another way how you can double check. So what I did here was I typed in the original left-hand side where the variable was located. All right, so that was 4, and then in parentheses 2x plus 7 and then close parentheses plus 4x. Now we figured out what x was, so I'm going to put parentheses around it, and I'm going to plug in the value for x, which we determined was 4. So I'm going to replace x with 4, and I'm also going to replace x with 4 right here. And that was actually a subtraction sign. All right, so now that I replaced x with 4 and I replaced x with 4, I can see that my left-hand side is now equal to 20, and my right-hand side was originally equal to 20. So that's how I can check my work. For the next example, I find the equal sign. I split the left-hand side from the right-hand side. Left-hand side doesn't have anything that needs to simplify, neither does the right-hand side. But I notice that my variable is on the right-hand side. What am I doing to my variable? Well, I'm dividing it by 3, and I am adding 2. All right, so we get rid of the addition first. We get rid of what's farther away from the variable, and that is the addition. So the opposite of add 2 is subtract 2. And if I'm going to do it to one side, I have to do it to the other side. So 2 minus 2 zeros out. That just leaves me with k divided by 3. And then on the left-hand side, I'll have 6 minus 2, which will give me 4. And then don't lose your equal sign. So now on the right-hand side, I just have k divided by 3. The opposite of divide is multiply. So I'm going to do the opposite of divide by 3, and I'm going to multiply by 3. And if I multiply by 3 on the right-hand side, that means I'll have to multiply by 3 on the left-hand side, which will give me 3 times 4, which is 12, equals, well, we said divide by 3, multiply by 3 cancels out, so that's just equal to k. And again, you can double check. So I have the right-hand side here. It was k divided by 3 plus 2, but we just found the value of k to be 12. So I'm going to put parentheses around that, and I'm going to type in 12. And this gives me 6, which was what the left-hand side was. So that tells me my answer is correct. Notice problem number 4 is slightly different than problem number 3. It still has a fraction. However, there's multiple operations within that fraction. All right, so with fractions, the way you can think of it is you can put parentheses around your entire numerator. You can put parentheses around your entire denominator. I'm not going to do that for the denominator since there's only just one number. But in the numerator, since there is more than one operation, I'm going to put parentheses around it. All right, so right now in my numerator, I have parentheses, but then I also have divide by 5. So I can think of it as parentheses and division. So going backwards and using order of operations backwards, I need to get rid of division before I get rid of the parentheses. So the opposite of divide is to multiply. So divide by 5, I would then need to multiply both sides by 5. All right, so that would give me negative 15 equals what was inside the parentheses, which is negative 2x minus 3. Because the divide by 5, multiply by 5 cancels out. And now I no longer have operations that are trapped within a fraction. So now I can work inside the parentheses. So now what do I have inside the parentheses? Well, I have 2 minus signs, but this is negative 2. You need to ask yourself, negative 2, what's it doing to the x? Well, negative 2, how would you say that? Well, I'd say this is negative 2 times x. So there's multiplication here. And then we are subtracting 3. So there's multiplication and subtraction. So we need to get rid of the subtraction before the multiplication. So we need to add 3 to get rid of the subtraction. And that's going to give us that negative 12 is equal to negative 2x. And then we get rid of the multiplication. Opposite of multiply is divide. What are we multiplying x by? We are multiplying it by negative 2. So we need to divide both sides by negative 2. And negative 12 divided by negative 2 would give us positive 6 equals, again, the negative 2 divided by negative 2 cancels out. So that will just leave us with x. So final answer is x equals 6. Again, how you can check is go back to the original equation. We need this expression to equal negative 3. So I'm going to type this into Desmos. So negative 2x minus 3, highlighted it, divided by 5. All right, that gives me this entire fraction. But now I'm going to replace x with the value that I found it to be equal to, which was 6. So I put it in parentheses, and now all of this expression is equal to negative 3, which is what I had here, which tells me I'm correct. The next question looks complicated because of fractions, but thankfully we are now going to be using calculators. Desmos can do the fraction work for us. All right, so same process. Here's the equal sign. So I'm going to split the left-hand side from the right-hand side. I see if I can combine any like terms or distribute anything, which I can't. All right, so now I need to figure out, okay, here's the variable x. What am I doing to the variable? Well, I'm multiplying it by -2/5, and I'm adding 7/2. So I'm multiplying and I'm adding. So what do I need to get rid of first? Well, that's the addition. So the opposite of adding 7/2 would be to subtract by 7/2 on both sides. And this is where the calculator is helpful. So what I can do is I can go over to Desmos, and I have -1, and then I am subtracting 7/2. So minus and then 7/2, and that gives me -4.5. However, I want the fraction. So I'm going to click over here for fraction form, and that's -9/2. So I'll put that into my work. So now I have -9/2 equals 7/2 minus 7/2 zeros out. It cancels out, and that's going to leave me with -2/5 times x. All right, so again, that we got rid of the addition, so now we get rid of the multiplication. The opposite of multiply is divide. So I'm going to divide by -2/5, and if I'm doing that on my left-hand side, I need to do that on the right-hand side as well. And again, I'm going to go back to Desmos, and I'm going to let Desmos do the work for me. So here I have my first fraction, -9/2, and then I'm going to divide. So I'm going to hit divide on my keyboard. And then I'm going to type in -2/5. So -2 divided by 5. Whoops. Clicked off. All right, so now I need to get back into the denominator there. So divided by -2/5. All right, that gives me 11.25. Again, I come over here to the fraction button, and it converts it to this improper fraction. So that tells me my answer is going to be 45/4. All right, so the -2/5 divided by -2/5, those cancel each other out. Multiplication and division undo each other, so I'm left with x equals. And again, my answer was 45/4. Here I'm back to Desmos to check my answer. So it was -2/5x plus 7/2. I'm looking to make sure that when I plug in 45/4, this is going to give me -1. So I'm going to replace x with 45 divided by 4, close parentheses, and that does give me -1. This next problem looks a little bit different because it says find the value of 2x plus 1 if 5x minus 3 equals 7. So this is giving us the conditional. It's telling me that I need to solve this equation first. I'm going to find the value of x, and then I'm going to take that value, multiply it by 2, and add 1. Notice this right here, 2x plus 1 is not an equation. I can't solve it. All right, 2x plus 1, this is just an expression. All right, so what I need to do is start off with my equation and solve it. So for my equation, here's my equal sign. So I'm going to divide the left-hand side, split the left-hand side from the right-hand side. On the left-hand side, I'm multiplying x by 5, so I have multiplication, and then I'm subtracting 3. So undo the subtraction first by adding 3 to both sides. And then that's going to leave us with 5x is equal to 10. And then to get rid of the multiplication, the opposite of multiply is divide. So we're going to divide both sides by 5. 5 divided by 5 cancels, leaving us with x equals 10 divided by 5 would give us 2. All right, now we're not quite finished with that yet because we said that now we want to evaluate, well, 2 times that answer plus 1, what is that? So now we're going to replace x with 2 and evaluate. So 2 times 2 would give me 4, and then 1 more than that would give me 5. All right, so this is a conditional. Solve the equation first, and then plug it into the expression to figure out what that would be equivalent to. Our last example is a little application problem. It says the perimeter. Perimeter means outside. So perimeter means add all of the sides. The perimeter of the triangle is, remember, is a keyword for equals, is 51. All right, so this perimeter equals 51. So what we need to do is we need to write an expression that represents the perimeter. So remember, perimeter means adds all the sides. So we're going to take 5a plus 5a plus 6a plus 3. So here's our equation. 5a plus 5a plus 6a plus 3 equals 51. All right, so here's the equal side. We're going to split the left-hand side from the right-hand side. And on the left-hand side, notice we're saying 5a, 5a, 6a. Those all sound the same because they are like terms. So 5a plus 5a plus 6a, they all have a to the first power, so we're going to combine the numbers in front of them, called the coefficients. So 5 plus 5 is 10, plus 6 more would give us 16. So we have 16a, and then we still have plus 3, and then equals 51. So notice that we have the variable on the left-hand side. We are multiplying it by 16, and we are adding 3. So we need to undo the addition first by subtracting 3 from both sides. Positive 3 minus 3 zeros out. They cancel out, which is going to leave us with 16a equals, and then 51 minus 3 is going to give us 48. All right, and then multiplying, to get rid of multiplication, we divide. So we're going to divide both sides by 16, divide both sides by 16, and that's going to leave us with a is equal to 3. All right, so then you can double check replacing these expressions for their actual side lengths. So 5 times a, so 5 times 3 would give us 15. So the side length of xz is 15. Replace a with 3. 5 times 3 again is 15. So these two sides are congruent. They have the same measure. And then here we have 6 times 3 plus 3. All right, so we're not solving an equation. We're not working backwards. So we're going to do 6 times 3 first. So 6 times 3 is 18 plus 3 more. This would give us 21. So to double check, we add these numbers up. So 15 plus 15 makes 30, plus 21 more is in fact 51, which is the perimeter.